to another edition of Williams Guide to Mathematics. In this lesson, we are taking a look at the topic probability. But before I go into the details of what probability is all about, I would like to give you a breakdown of what our lesson 1 of probability will be. The first thing, we'll be talking about facts on probability. Secondly, we'll be talking about probability formula. And lastly, we end it up by solving some problems involving probability. Now, let us start with the first point, which is facts about probability. Now, the question is, what is probability? When you say something is probability, or something is probably going to happen, it means that thing is not certain. That means you are trying to measure the chance of that thing happening. Maybe it will happen, maybe it will not happen, or the degree or the extent to which that thing will happen. So we can define probability as a measure of the chance of an event happening. Again, probability is a measure of the chance of an event happening. Now, I said it talks about the measure. The value of probability is between 0 and 1. So we say the value of probability is 0 less than or equal to probability less than or equal to 1. That means we can only have answers between 0 and 1. Look at this number line, for example. In the number line I have on the screen, we have 0, we have 1 at the end, at both extreme ends, 0 and 1. Now, my 0 and 1, I have some other divisions in between. If I have a probability that is in between, which is exactly half, that indicates that the probability is half, 1 over 2, exactly in between. If I have a probability of 0, it means that thing will not happen. It is not possible to happen. If I have a probability of 1, it means that thing is certain to happen. Now, imagine I have a probability indicated above. It means the chance of that thing happening is very, very slim. Look at the other one now. If I have a probability of a case like this, it means the chance of such an event happening is very, very high. So our second point on probability talks about probability ranging from 0 to 1. Again, we cannot have a value less than 0. That means that is negative values. We can also not have a value that is more than 1. That is something like 1.1, 1.2, even 1.03 something. We can't have such values. Our values are limited to 0 to 1. Now let's take our third point. Probability could be expressed as either a fraction, a decimal, or a percentage. That means I can have my probability in form of fraction. Take for example the number line I showed earlier. We have half. If I'm to change it to, that is fraction. If I'm to change it to decimal, I will have 0.5 for the decimal equivalent. If I also change it to percentage, I will have 50%. So our probability can come in form of fraction, decimal, or percentage. Finally, we say that the probability of success plus the probability of failure is equal to 1. Again, the probability of success plus probability of failure is equal to 1. If I choose to make the probability of failure the subject of formula, I will have 1 minus probability of success. Now, this is not a success-failure relationship alone. It goes with any problem that has to do with word and opposite, or we say complementary. It could be good and bad. That means probability of good plus probability of bad is equal to 1. It could be even and odd. Even numbers and odd numbers are complementary events, meaning if a number is not even, it will definitely be odd. So I can say that probability of even plus probability of odd is equal to 1. Let's take a good look at the first example. We're told that if the probability of picking a good fruit is 5 over 8. The probability of picking a good fruit is 5 over 8. The question is, what is the probability of picking a bad fruit? Now we have some fruits, 5 over 8 we are told that that is what we have for good. That means 5 out of 8 is taken to be good. So we have 8 fruits in total. 5 of the 8 are good. The question is, how do we get the probability of the one that is bad? Now, if 5 out of 8 of the fruits are good, it means we are having 3 over 8 left. That means 5 out of 8 of the fruits are good. What is remaining? Just 3 out of 8. So to get this, we'll do 1 minus 5 over 8. Remember, from the relationship of probability of success plus probability of failure is equal to 1. In this case, we are dealing with probability of good fruit plus probability of bad fruit. So to get the probability of bad fruit, it will be 1 minus 5 over 8, which is definitely 3 over 8. Another example. The question says that the probability that it will rain is 3 over 4. The probability that it will rain is 3 over 4. What is the probability that it will not rain? Now, remember I said for complementary events like good and bad, success and failure, when we add these two events together, the probability of these two events, we get 1. So the probability it will rain has been given to us as 3 over 4. That is 3 out of 4. So the probability it will not rain will be 1 minus probability it will rain. That is 1 minus 3 out of 4. So if I have 3 out of 4 as it will rain, then I'm only having 1 left. 1 out of 4 that it will not rain. Definitely 1 minus 3 over 4 equals 1 over 4. Having taken these two examples, let us talk about the probability formula. The probability formula is equal to the number of required outcome over number of possible outcome. Again, number of required outcome over number of possible outcome. Let me shed more light on what I mean by required outcome and possible outcome. Required outcome, from the word required. Required means what the question is asking us for. So if the question is asking me for the probability of picking a bad fruit, that means that I'm to get the number of bad fruits. If the question is asking me the probability of picking a red ball, that means I'm to get the number of red balls. For total outcome, that means we are talking about everything given in the question. By the way, we can also take total outcome to be what we call sample space. So anytime you hear the word sample space, it also means total outcome. In this example, we have 500 fruits in total. I can take my 500 fruit to be the total outcome or the sample space. We are also told that 25 of the fruits are bad. By the way, we are being asked to get the number of good fruits. The number of good fruits will be 500 minus 25, which is 475. So I can get the probability of picking a good fruit, probability good fruit, I can get that to be number of good fruits over the number of possible outcome. Number of good fruits over the number of possible outcome. And that will be the 475 we got by subtracting 525 over the 500. And that will give us 19 over 20 after reduction. Another method I can use to do this is I can get the probability of the bad fruits, which is 25 over 500. 25 because we are told that 25 of those fruits are bad. And the total outcome is 500. That will give us 1 over 20. Then I will apply one of the facts of probability. The probability of success plus that of failure is equal to 1. In this case, I will use probability of good plus probability of bad is equal to 1. So the probability of good will now be 1 minus that of bad, which is 1 minus the 1 over 20 we just got. And that is 19 over 20. Either method is fine. the example 4 of this lesson has a table. The first question is asking us how many students are there. Now, to get the number of students, we add the frequency. We have 11 plus 8 plus 5 plus 4 plus 2. 11 plus 8 is 19. 19 plus 5 is 24. 24 plus 4 is 28. And 28 plus 2 is 30. Meaning the number of students that are there, they are 30 in number. That answers the first question. The second question is asking for the probability of 40. The probability of 40. The probability of 40 is the number of students that got 40, which happened to be 8. So 8 over the total number, which is 30. So we have 8 over 30, which I can reduce to be 4 over 15. Above 50% is talking about those who scored more than 50%. If you check the table, the last two columns address that. That is those who scored 60 and those who scored 70. The number of those who scored 60 is 5. We can see that in the table. And those who scored 70 is 2. So we add the 2. That is the number of required outcome. 5 plus 2, that is 7 over the possible outcome, which is what? 30. So our answer is 7 over 30. And finally, we have in the question at most 40. At most 40 means not more than 40. So if you look at it, the table, we have the score of 30, we have 40, we have 50. Of course, 50 is more than 40. So we stop at 40. So we take 30 and 40. 11 students scored 30, 8 scored 40. So our number of required outcome will be 11 plus 8. That makes it 19. So we have 19 over the possible outcome, which is 30. So the answer for probability at most 40 will be 19 over 30. Here comes the last example. In this example, we have 3 different colors of balls, though they are identical. We have black, we have red, and we have white. The number of black ball, according to the question, is 2. The number of red ball is 3. And the number of white is 6. The first thing I will do, irrespective of whether the question is asking me or not, as long as I'm solving the probability question, is to add the total number of balls. That is 2 plus 3 plus 6. And that will give me what? 11. So my total number of balls, which is my possible outcome, which is also my sample space, is 11. Now let's take the first question. The first question is asking for the probability of picking a black ball. The question is, how many black balls do we have in this question? Yes, it is 2. So the answer to my question is 2 over 11, because we have 2 black balls in the question and we have 11 balls in total. Secondly, we are asked to get the probability of picking a red ball. Again, how many red balls do we have in the question? Oh, your guess is as good as mine. It is 3. That means we have 3 out of 11. So we have 3 red balls and we have a total of 11. So that makes it 3 over 11. The next question is probability of picking a white ball. How many white balls do we have in the question? Oh, we have 6 white balls in the question. That is 6 out of how many? 11. So the number of required outcome, which is number of white, is 6, and the total balls we have in the question is 11. That leaves us with 6 over 11. The fourth question is asking for probability not red. If it is not red, it is what? In the bag we have black, red, and white. So if it is not red, it is either black or white. So how many black do we have? 2. How many whites do we have? 6. So we add the 2 and the 6 because we can pick either of the 2 balls. 2 plus 6, that is 8. So the number of required outcome, which is either black or white, is 8 over 11. Alternatively, we can decide to get the probability of picking a red ball, which we've gotten earlier, as 3 over 11. And going by our probability of success and failure relationship, we can get the probability of not red. If the probability of picking a red ball is 3 over 11, then the probability of not picking a red ball will be 1 minus 3 over 11. Again, that means if 3 out of 11 is red, then the remaining is not red. So the remaining is 8 over 11. So far so good, we've come to the end of this interesting topic, probability. We talked about some facts about probability, we talked about the probability formula, and we solved some problems involving probability. It is a lesson that is continuous. It is not going to be limited to this lesson alone, meaning there are some lessons after this about probability, and it will be good you follow up all these lessons. To get more of these lessons, you can subscribe to the YouTube channel, Williams Guide to Mathematics. We do not disappoint there. We encourage you to persevere. We encourage you to work with high level of accuracy, and we encourage you to simplify your work. And finally, we try to help you to increase your speed. So P for perseverance, accuracy, that is A, simplicity, that is S, and we have one more S, that is speed. If you join all those 4 letters together, it means pass. That is what we preach in mathematics. We encourage you to do very well, not just well, but very well. I'll see you again very soon for our next lesson on probability. Before then, stay blessed.